Using the upgraded Giant Metrewave Telescope, Indian astronomers have succeeded in measuring the atomic hydrogen content of around 8,000 distant galaxies. According to the astronomers of National Center for Radio Astrophysics, Pune, and Raman Research Institute of Bangalore, the findings of their study explain the declining rate of star formation to a great extent. The joint research has been published in the journal Nature.
Stars, the twinkling objects in the sky, have always attracted human attention. But according to astronomical studies, the rate of star formation in the universe is dropping continuously after it peaked about 8 to 10 billion years ago. And the astronomers are wondering what happened in the earliest epoch of the universe. Recently, a team of astronomers from the National Center for Radio Astrophysics of the Tata Institute of Fundamental Research, Pune, and the Bangalore-based Raman Research Institute has managed to answer this question. The astronomers have succeeded in recording the earliest epoch in the universe by measuring the atomic hydrogen gas content of the distant galaxies as they were 8 billion years ago. Their study has deciphered the mystery behind the decline in the star formation activity, and the research has been published in the research journal Nature. Galaxies contain a lot of gas, mainly the atomic hydrogen that converts into stars with time, as it is the primary fuel for star formation. But unlike stars which emit light strongly at optical wavelengths, the atomic hydrogen signal lies at the radio wavelength of 21 centimeters and therefore can only be detected with a radio telescope. The Giant Metrewave Radio Telescope at Pune was designed and built in the 1980s and 90s for the same goal. With the earlier version of GMRT, astronomers could study only 850 galaxies for similar research in 2016, but that wasn't enough. The situation changed with the upgradation of GMRT in 2017, which enabled the scientists to detect the signals of about 8,000 galaxies dating back to 8 billion years. As the 21 centimeter signal is fairly weak, so it was not possible to detect the signals from the individual galaxies. To overcome this limitation, the team used a technique called stacking to combine the 21 centimeter signals of nearly 8,000 galaxies and measured the average gas content of these galaxies.
There is a limited amount of gas and there is no more gas falling into the galaxies. So after some time, all the gas will get converted to stars and that's when you will expect the star formation to start declining. And what we find is that there's just enough gas for the star formation to sustain for about 2 billion years, 1 to 2 billion years. So after 1 to 2 billion years, from our measurements, we would expect that the star formation rate would start to decline. And this is exactly what we see, that the star formation rate, what we have known for 2 decades now, that the star formation rate declines after it, from that epoch, after it has peaked from 8 billion years to now.
The research funded by the Department of Science and Technology and Department of Atomic Energy not only highlights the successful collaboration of Indian astronomers at NCRA and RRI, but also the telescopes like GMRT that allow us to peer into the universe to unravel its mysteries.
Mm-hmm.